today we are going to learn about simplifying expressions. This is 2.3. You have 1.7 on your notes. Put 2.3. It's 2.3, combining like terms. Your target is you can simplify expressions. Vocab that you need to know is terms. Terms are part of an expression. They are what make up the expression. So terms are part of an expression. The example that I have is 4 plus 3x plus y plus 7. The 4 is a term. The 3x is a term. The y is a term. And the 7 is a term. They are all terms. They're all part of that one statement. Like terms have the same variable connected, right? They're like terms if they have the same variable or letter connected. So like terms have the same variable connected. I like to distinguish my like terms with different types of lines. I usually will start with circles. 4a and 6a are like terms. They both have an a. And then some students like to color code, some like you just find your way that you like. 5b, I usually will do a different type of line. The 5b goes with the 4b. They are alike. So you try to keep the like items together. Coefficients. Coefficients are numbers in front of a variable. It's a vocab word that is going to be your best friend. They are numbers in front of a variable. For example, 5x, my coefficient isn't 5x. You don't say 5x, it's just the number. My coefficient would be the 5. If I had negative 1/3 x, my coefficient would be negative 1/3. It would be the number that's sticking in front. So my coefficient would be negative 1/3, not negative 1/3 x. A constant has no variable connected, okay? Constant has no variable connected. It stays constant, it doesn't vary. If I had negative 5x plus 3 plus 2a plus 4, my constants are the ones that don't have that variable. 3 is a constant. 4 would be a constant. They're not varying, they don't have a 4 or a variable connected to it. Next page is identifying parts of an expression. You will have to do this in your homework. I suggest in your homework you do it similar to how I have it set up here. Make a chart that has terms, like terms, coefficients, and constants, depending on what they're asking for. So looking at this expression, it's an algebraic expression because there's letters. I want to identify what are my terms. What's one term? Give me one. 3x is a term. It's a part of the expression. I did it. What's another term? What's another part? Ethan? 2y is another term. It's another part. 4x is another part. Y is another part. And our constant of 3 is also a term. Now, like terms. What are alike? Ethan? 3x and 4x. So I will just say 3x, comma 4x. They're like terms. constants. Do I have other like terms? Jada?
2y
2y and y. They are alike. And then we don't have anything else. Coefficients, the number in front of the variable. So what kind of coefficients do I have, Maxwell?
3.
3, that's in front of x. Good, got it. Anything else? Wait, Isabel? 2, number in front of a variable. Sarah?
4.
4, number in front of a variable. Yep, Alex?
Another 3.
Another 3 is a constant. What's that little stinker that's
1.
not doing anything? Isabella? 1. 1 is all alone. It likes to disappear. It's so shy. We try to call it out whenever we can. And our constant would be the 3. There's no letter connected. So I'm just going to show you real quick an example. What your book describes. It says, this is not the right section. Name the coefficients, like terms, and constants. So I would say the coefficients, I would make a chart like this. Coefficients, like terms, and constants. And I would just label them the way I did in that previous example. So coefficients for this expression would be a 3 and a 4. 3 and 4 is sticking in front of a variable. Like terms, now funny, this is going to have 2 sets. I have a 3a and a 4a, they're alike. They like to hang out together. Constants are also like terms. You can combine constants. So I'm going to say and the 2, this is not a positive 1, this is a negative 1. 2 and negative 1. Those are like terms too, like constants. And our constants are 2 and negative 1. You will be counted wrong if you write just 1. So be careful for that. I'm not going to worry about that next example. We'll switch pages. All right, the reason why we need to be able to identify parts of an expression is to simplify, which was our learning target. You can simplify expressions. When we simplify, we need to know what like terms are, we need to know what constants are, and then we try to just combine everything we can. So, if there is, here's some rules. If there is nothing in front of a variable, it is a 1. That's something you just need to always keep track of. If there is nothing in front of a variable, it is a 1. Remember, 1 is really shy. It only shows up when you make it appear. If there is a minus sign in front, we're going to add the opposite, okay? Or a plus, a negative, however you want to think of it. So if there is a subtraction or minus, I'm going to choose minus as my vocab. If there is a minus sign in front, make sure we add the opposite. Or plus and negative. Maybe you like to say plus and negative. Same thing. Examples. X plus 4 plus 4x plus 8. I start from the left. I first off say, hey, I'm making the 1 appear. Hey, 1, what's up? Try to be all shy. 1x connects with what? What can I combine 1x with? Just say it. 4x. So 1 plus 4x is?
5x.
So this is going to be 5x. So I'm done with my constants, my variables. Now I have my, or I was done with my variables. Now I have my constants. 4 plus 8 is what? 5x plus 12. I leave it like that because I can't combine them if they're not like terms. That is not 17x. All right, 3s plus 4f minus s plus 3f. I see this minus. and I plus the opposite. I plus a negative. Starting from the left, 3s plus a negative s. How many am I at? 3 plus a negative 1. I'm at 2. 3 plus a negative 1, because this is a 1 in front, I'm at 2. This turns into 2s. Now I have my f's. 4f plus 3f is how many? 7 f's. It is not 9sf, it's just 2s plus 7f. Because they're not like terms. They don't have the same variable connected. All right, I want you to do this next one. Remember to plus a negative first. Looking at this, I see a lot of subtraction signs, so I'm going to turn it to plus a negative, just so I realize that it's a negative number. Starting from the left, I have 4x plus a negative 6x. I'm at negative 10, negative 10x, plus 3x. Negative 10 plus 3 is a negative 7. So I have negative 7x. Now I can do my constants. 3 plus a negative 5, I'm at negative 2. So I can write plus a negative 2, not done, because I have 2 signs in the middle. I always only want 1 sign in the middle. So you have 2 signs in the middle here. So does plus a negative mean I add or subtract? Subtract. So I rewrite this as negative 7x minus 2, and I am done. So the rule is if they're the same sign in the middle, you add. It's like multiplication rules. Same sign, positive, different signs, negative. Same sign you add, different sign you subtract. I see more subtraction on this next example. I add the opposite, add the negative, plus a negative. I'm starting with my constant first. 13 plus 5. 13 plus 5 is 18. Now I have my b next. Negative 2b plus 7. Negative 2 plus 7 is 5. That's it. So plus 5b. And then I have my a. 12a plus a negative 8a would be 4. And I would be done, but I'm not that beautiful as I want it to be. I want letters first in alphabetical order. 4a plus 5b plus 18. Now, people in math world are extra happy because I have good etiquette. That's it. That's all you need for today. Okay, we're going to simplify using distribution. Simplify expressions using distribution. Distribute first. That's all that's different. Distribute, then combine like terms. First distribute, second combine like terms. Distribution is always the most important thing in the whole entire world to do. Okay? So I'm going to distribute first. 4 times 2 is 8x, plus 4 times 3 is 12, plus a negative 2x. Now I combine like terms. 8x plus a negative 2 would be 6. 6x plus the constant of 12. Call it done. Oh, look at that ugly one. Negative 3x minus 4 minus 9. This is negative 1 times everything. I'm going to distribute. Negative 1 times 3 is a negative 3x. Minus a negative 1 times 4 is a negative 4 minus 9. Oh, look at how crazy that looks. I'm going to change it to plus the opposite. Negative 3x plus the opposite of negative 4 is just 4. Plus the opposite of 9 is just, or of 9 is negative 9. So this is plus, plus, and then